Good morning, everybody. Welcome back to American Safety Programs and Training. Chapter review for Chapter 16, Cardiovascular Emergencies. If you remember last chapter, Chapter 15, we talked about respiratory emergencies and how the lungs work, how we exchange oxygen and waste in the lungs, how important it is to the human body, how important it is to survival. No oxygen, we don't live. And how it gets transported throughout the body and what type of emergencies we run into, difficulties we run into, and why it's important that as EMTs we understand how important it is and things that we can do to either whatever's going on, we can either slow it down, stop it, and get the patient transported to the hospital for definitive care with the doctor and nurse and get them taken care of. Even more so, equally so, are cardiovascular emergencies, Chapter 16. Cardiovascular, myocardium, the heart. If the heart's not working, we're not living. Simple as that. The heart is the engine. It is the pump for the cardiovascular system. The cardiovascular system is made up of three separate things. It's made up of the pump, which is the heart. It's made up of the pipes, which is the arteries, veins, and the capillaries, and the fluid inside the pumps, or the fluid inside the pipe, the blood. Now, what's so important about blood? Well, as you know, last chapter I talked about the hemoglobin on the blood and what blood is made out of. Blood is made out of four components. It's made out of red blood cells, white blood cells, platelets, and plasma. Red blood cells have part of it that's called the hemoglobin. That hemoglobin is what oxygen latches onto and CO latches onto in order for it to be transported throughout the body. And whenever the oxygen is needed, after it's got the piggyback rides to the part of the body where it needs the oxygen hops off and the CO hops back on, and when that red blood cell makes it back up to the lungs, the CO jumps off and we exhale it. White blood cells fight infection. Platelets are a little bit smaller than red and white blood cells, but they are very sticky, and we know that they help with clots, forming clots to help stop bleeding. And plasma is basically the liquid that the platelets, the white blood cells, and red blood cells use to be transported throughout the body. But also plasma also carries a lot of other things, minerals, vitamins, and also helps carry waste as well. So the blood is what goes through the heart, okay? And we're going to discuss the blood flow through the heart in a little bit of detail here in this chapter. If you want to get started on page 629, we're going to go page by page. I'm also going to use a PowerPoint as a reference as well to make sure I'm staying on track, and I try to keep everything going nice, smoothly, flowing for you so you can understand everything. Okay? So the heart. The myocardium. Okay? We all know how important the heart is. If you don't have a heart, you're not alive. If the heart's not working right, then other parts of your body are affected as well, just like with the lungs. There's always a domino effect. So the heart. The heart, as you know, is in this little shape right here. Okay? And the heart is made up of four chambers. The two upper chambers are called the atrium, or the atrius, and the two bottom ones are called ventricles. Okay? So, if you've ever seen a fire truck on a fire scene, the fire truck is shooting water out through the hoses trying to put the fire out. Well, a fire truck only has so much water on it, so the fire hose has to get resupplied. And they resupply by hooking a larger hose, what they call the main line, they connect it to a fire hydrant. They open up the fire hydrant resupplies the water to the fire truck as the fire truck is pumping out water to put out the fire. With the human body, the pump, which is the heart, it needs to get resupplied just like that fire truck. So the main line that returns blood to the heart, go back 2 steps. The heart pumps blood to the body. When the blood goes out, it goes everywhere from the top of our head down to the bottom of our feet. But it's got to come back to the heart. When it comes back to the heart, it comes back through what we call a main line, otherwise known as the superior and inferior vena cava. The vena cava. Superior vena cava means that it's above, and inferior means that it's below. So it's above the heart or it's below the heart. But the vena cava is on the right side of the body. Okay? It's on the right side of the heart. So as blood from the lower portion of the body comes up through the inferior vena cava, blood from the upper part of the body comes from the superior vena cava. They both meet and they return deoxygenated blood that has very little oxygen in it, back to the heart, and it comes into the upper right atrium. Now, whenever blood comes back to the heart, it always comes back to the heart at the top of the heart. Then it goes to the bottom, then it goes back out the heart. But it does it in two separate ways, depending on each side of the heart. So the right side of the heart, deoxygenated blood from the inferior and superior vena cava comes back and it enters the heart in the upper right atrium. It goes from the upper right atrium, it goes down to the bottom right ventricle. From the bottom right ventricle, it goes out to the lungs, kicks off all the CO and waste that's in it, and we exhale it, and then it holds on to as much oxygen as possible. It gets oxygenated. And when blood, let's color code it. When blood comes back to the heart, let's say it's a blue color, okay, because it's deoxygenated, doesn't have that much oxygen. Comes into the upper right atrium, goes down the bottom right ventricle, goes out to the lungs, gets rid of all the waste, picks up all this oxygen, and then it comes back from the lungs, back to the heart, and it comes back to the upper left atria, goes down to the bottom left ventricle, and then it goes out through the aorta, and it goes to the rest of the body. Okay? Now, when blood is being transported through the body, you need to have pressure build up. You need to have pressure in the system, in the cardiovascular system. Just like in a car's engine, you need to have pressure in order for the engine or the pump to work effectively. With the human body, we call that blood pressure. When we take blood pressures, which I'm sure you guys have already learned about vitals, you got blood pressure, pulse, respiration, along with a couple of other things. But blood pressure, you have two separate types of blood pressure. Blood pressure is broken down into two separate things. You've got a high number and a low number. The high number is called the systolic blood pressure, and the low number is called the diastolic blood pressure. So say somebody has a blood pressure of 120 over 80. 120 represents the pressure that is in the arteries when the heart is squeezing. When that heart squeezes, it squeezes all that blood out through the body under a lot of pressure, and that's called the systolic blood pressure. When the blood returns to the heart, and as the heart is filling back up, the heart is sort of resting a little bit, so that's called the diastolic blood pressure. Okay? It's the residual pressure that's within the cardiovascular system when the heart is being refilled. So you have the systolic and the diastolic. Systolic represents when the heart squeezes. Diastolic represents when the heart is refilling. Now the heart, there's something that's called the septum that divides the heart into the right and left-hand side. Remember that, septum. Okay? So, when we're talking about the heart and the blood flow through it, a lot of people aren't quite sure that when the heart pumps, how does it pump? Well, it pumps like this, right? Okay, well, it basically does. But you've got the two upper chambers and you got the two lower chambers. Do they all four pump at the same time? They don't. They actually pump. The two upper chambers pump first, and then within a millisecond, the two lower ones pump. So you got top, bottom, top, bottom, top, bottom, top, bottom. They don't go like this. They're like this, top, bottom, top, bottom, top, bottom. But they do it so quickly, it's very close. So like maybe 1 to 0.2 of a second difference. What causes the heart to pump? What tells the heart when to pump? The brain? Yes, it does tell it when to pump. But what makes it pump? What makes that muscle squeeze? Because the myocardium, the heart, is a muscle. And remember, you have three different types of muscles in the body. You've got the cardio, you've got smooth muscles, and you've got skeletal muscles. Okay? So, myocardium, the heart, what makes it pump? This is what I think is really cool. The heart actually pumps because it's told to, and it gets shocked. The heart actually generates its own electricity, and that is called automaticity. Okay? The heart actually gets shocked, and when you get shocked, what do? You jump. Well, in the case of the heart, it pumps. So what happens is, up in the upper portion, in the upper right atria of the heart, is something that they call the SA node. Okay, the SA node is where the electrical shock starts. Once the heart builds up electricity, SA node shoots out electricity. And picture you have a scoop of ice cream and you're pouring chocolate syrup on it. That chocolate syrup goes all over that scoop of ice cream in the front, the back, on the sides, nice and evenly. Okay, that's what the electricity does when the heart shocks itself. It starts on the right, it jumps over to the left, and at the same time, both on the outside and the inside of the heart, the electricity goes down, goes down, goes down. Starts at the top, works its way to the bottom. So when the top gets shocked, the two atrias, they both squeeze, they both pump. And as electricity goes down, which is about 1 to 2 tenths of a second after the initial shock starts, then the electricity goes to what they call the AV node, and that helps to direct the electricity down the rest of the heart, and it goes down the front of the heart, the back of the heart, and both sides of the heart nice and evenly, and then that causes the two ventricles to squeeze. As the atria squeezes, they're full of blood, they squeeze, and the blood goes through a valve. It's a one-way valve called the tricuspid valve. It doesn't allow blood to come back up. So the atria squeezes up here on the upper right, squeezes the blood down, okay, into the bottom right ventricle, and at the same time, the upper left ventricle is squeezed at the same time, squeezing blood down to the ventricles. And then about 1 to 2 tenths of a second later, the ventricle squeeze. When the right ventricle squeezes, it squeezes that blood to the lungs to get rid of all the waste and to pick up a bunch of oxygen. And when the left ventricle squeezes, the left ventricle is also the thickest and the strongest part of the heart, because when the left ventricle squeezes, that's when all the blood goes out through has enough pressure where it goes throughout the entire body. When that squeezes, all the blood goes out. Okay? So blood comes in through the superior and inferior vena cava, comes into the upper right atria. It gets shocked from the SA node from a process that's called automaticity. It squeezes, it goes through the tricuspid valve down to the bottom right ventricle. Okay? Then from there, it goes through the pulmonary artery. It goes through the pulmonary artery, and it goes out from the heart to the lungs, picks up a bunch of oxygen, drops off a bunch of junk, comes back through the pulmonary vein, and it comes back to the upper left atria. Upper left atria squeezes, it goes through, not the tricuspid valve, it goes through the bicuspid valve. Try it before you buy it. Tricuspid's on the right, bicuspid's on the left. Try it before you buy it. So it comes up, it returns to the heart in the upper left atria, goes through the bicuspid valve, also known as a mitral valve, goes down, that's a one-way valve as well, goes down to the bottom left ventricle, and it gets squeezed out, and it gets squeezed out through the aorta to the rest of the body. Okay? So I hope I explained that correctly. Well, I hope I explained it in a way that makes sense. So blood comes in to the inferior and superior vena cava, upper right part of the heart, goes to the bottom right part of the heart, goes out to the lungs, picks up oxygen, drops off waste, comes back to the upper left portion of the heart, to the upper left atria, goes down on the bottom left ventricle, and it gets pumped out to the rest of the heart, to the rest of the body. Okay. Let's see. I'm talking here. Cardiovascular disease. Okay, we got that. Okay. Let's see. The one-way valves keep the blood from flowing in the proper direction. So it's a one-way valve because when the blood goes down, you want it to stay down. You want it to come back up. So that's why it's a one-way valve. Remember, when the blood goes from the upper right atria to the bottom right ventricle, it goes through the tricuspid valve. And then when blood goes from the upper left atria down to the bottom left ventricle, it goes to the bicuspid valve, also known as a mitral valve. Okay? If you guys want to, take a look at page 631. You're going to see how you have the SA node in the upper right-hand corner. The AV node is about in the middle of the heart, but it's at the top of the septum. Remember, the septum is a membrane that divides the heart between the left and the right-hand side. After that, you've got the bundle of His, which is basically, you can consider it like rope. Twisted rope, goes all the way down. And then that rope starts to, it breaks up. And as you can see, some of it goes to the bottom right-hand side, some of it goes all the way to the bottom of the heart. And those are called the, when you have the bundle of His, and then it starts to divide, that's called the bundle branch. you have the right bundle branch and you have the left bundle branch. That's when the rope splits into two pieces of rope. And then as the rope gets down towards the bottom of the heart, it starts to untwingle, or become undone, and it's much smaller fibers, much smaller pieces. And if you look at that picture, it's called the Purkinje fibers. The Purkinje fibers are on the bottom of the heart. Okay? Let me see here. We talked about autoelasticity. So the stimulus that originates in the SA node is controlled by impulses from the brain, which arrive by the way of the autonomic nervous system. Okay? Now, the autonomic nervous system controls functions of the body that do not require conscious thought, such as the heartbeat, respirations, dilation, and constriction of blood vessels, and digestion of food. The autonomic nervous system does everything automatically for us. So that's an easy way to remember it. Okay? The autonomic nervous system is broken down into two parts: the sympathetic nervous system and the parasympathetic nervous system. The sympathetic nervous system is also known as the fight or flight system, which makes adjustments to the body to compensate for increased physical activity. What it does is that it speeds up the heart rate, increases the respiratory rate and the depth, dilates the blood vessels to increase blood flow to the muscles, and it constricts blood vessels in the digestive system. So basically, think of it this way. The sympathetic nervous system gets your body ready for physical activity. You're going to get ready to play football. You're going to get ready to play baseball. You're walking up. You're getting ready to take that swing. You're getting ready. You're boxing. You're getting ready to go into the ring for a fight. Okay? Your heart rate picks up. Your respirations pick up. Okay? Blood pressure. Blood vessels dilate to increase blood flow to the muscles because you're going to be experiencing a lot of physical activity, so your muscles are going to need a lot more oxygen. So that is the sympathetic nervous system. The parasympathetic nervous system works completely the opposite. That helps to calm you down. It takes those dilated blood vessels and it opens them up. Okay? The parasympathetic nervous system directly opposes the sympathetic nervous system. The parasympathetic nervous system slows the heart rate, slows down the respiratory rate, constricts the blood vessels. Okay, I apologize. I said earlier that it dilates them. The blood vessels dilate in the sympathetic nervous system, but the parasympathetic nervous system, it takes those dilated blood vessels and it reduces them. It says calm down, slow down. Okay? So the parasympathetic system slows down the heart and respiratory rates, constricts blood vessels and muscles, and dilates the blood vessels in the digestive system. Okay? Normally these two systems balance each other, but in times of stress, the sympathetic nervous system gains the primary control, whereas in times of relaxation, the parasympathetic nervous system takes control. So the sympathetic nervous system gets you ready for action, and the parasympathetic nervous system helps you relax. Okay? Now, we already talked about the blood flow of blood through the heart. Doctors and surgeons need to know at times how much blood is going through the heart. How do they measure that? There's no way that we can measure it in the field. So when doctors are looking at somebody, when surgeons are looking at somebody, they want to know what the stroke volume is. The stroke volume of the myocardium, or the stroke volume of the heart. The stroke volume refers to how much blood passes in and out of that heart every time it squeezes. Every time that heart squeezes, how much blood is it squeezing out? Is it squeezing out 4 ounces, 6 ounces, 20 cc's, 100 cc's? Okay? That's especially the cardiologists and doctors have a way of doing that. Okay? The stroke volume is the volume of blood ejected with each ventricular contraction. In the normal heart, increased oxygen demand of the myocardium, which is the heart, itself is supplied by dilation or widening of the coronary arteries, which increases blood flow. The coronary arteries are the blood vessels that supply the blood to the heart muscle. This chapter is going to cover a lot of stuff in a very short amount of time. So I'm going to do my best to not confuse you guys. So think of it this way. The heart is probably the greediest muscle in the body. The heart does a lot of work. The heart supplies the oxygenated blood for the rest of the body. So therefore, if it gives every part of the body the blood that it needs, it makes it the greediest part of the body. It makes it how can I say it? It wants all the blood first. When the heart pumps blood, it's going to take its supply first before it gives it to the rest of the body. It's going to take what it needs first. And it does that by having the coronary arteries supply the heart itself first. Now, you know the difference between an artery and a vein. An artery takes blood away from the heart, and a vein brings blood back to the heart. Okay? Whenever you look at pictures of arteries and veins in the body, you're always going to see that one's red and one's blue. Blue represents the veins because the veins are deoxygenated. So when you have deoxygenated blood, it's going to be a very deep, dark red. And when you have oxygen that's loaded with oxygen, it's very, very bright. If you ever poke your finger or cut yourself, the blood is red, but it's a dark red. But if you have arterial blood, when you have an arterial bleed, you're going to see that it's a very bright red. And that's why they color code arteries and veins the way that they do. Arteries are red, veins are blue. Now, as I said, arteries and veins. Arteries transport blood away from the heart, veins bring blood back to the heart. There's one time, one location in the body that is different, that is the other way around, and that is with the heart. Remember when I said that blood comes back or returns, deoxygenated blood returns to the heart via the superior and inferior vena cava to the upper right atria, and then it goes down to the bottom right ventricle, and then from the bottom right ventricle it goes out to the heart. It goes out to the lungs, picks up a bunch of oxygen, comes back. Okay? What happens is that when I said arteries take blood away from the heart and veins bring blood back, the one time it's different is in the heart when the blood from the bottom right atria goes out to the lungs. It's not going by an artery, it's going by a vein, the pulmonary vein. The pulmonary vein takes blood from the heart, out of the heart, to the lungs. And then when the oxygenated blood comes back to the heart, it comes back by the pulmonary artery. Okay, so remember, arteries take blood away from the heart, veins bring blood back. But the only time it's different is with the heart. When blood leaves the heart to go to the lungs, it's going out by the pulmonary vein. When blood comes back from the lungs back to the heart, it's coming back via the pulmonary artery. Okay, that's the only time it's different. So remember that. Great test question. Okay, so where were we? Page 611. The coronary arteries are the blood vessels that supply blood to the heart muscle. They start at the first part of the aorta, just above the aortic valve. The aortic valve is the valve that's inside the heart. When the blood enters the aorta, it's got to go through a one-way valve as well, and it goes through the aortic valve. Okay? The right coronary artery supplies blood to the right atrium and the right ventricle. And in most people, the bottom part or inferior part of the wall of the left ventricle. So, the right coronary artery supplies blood to the right atrium, the right ventricle, and the bottom of the left ventricle. So it's like an L shape. Okay? The left coronary artery supplies blood to the left atrium and the left ventricle and divides into two major branches in a short distance from the aorta. Okay? So the left coronary artery supplies blood to the left atrium and the left ventricle as well, but it also divides into two major branches. Those two main branches, or those two arteries, are called the carotid artery and the subclavian artery. Okay? Now the coronary artery, let's see, two major arteries branching from the upper aorta supply blood to the head and arms. The right and left carotid arteries supply the head and the brain with blood. So the carotid arteries are the ones that are alongside your neck, and they go up and they supply your brain and your head with the blood. Okay? The subclavian arteries The right and subclavian arteries under the clavicles right here supply blood to the upper extremities, to your arms. Okay? When the subclavian artery comes out and it starts to go down the arm, then that's when it becomes the brachial artery. Okay? A couple places where we can check the pulse. One of them is the carotid artery. The next one, when you're doing CPR on an infant, you're going to check the brachial artery. The brachial artery is on the inside of the arm, between the bicep and the tricep. It's right here. That's the brachial artery. Okay? As that artery continues to go down the arm, once it passes the elbow and it enters the lower part of the arm, it then becomes the radial artery. And where we check the pulse on a patient on the hand or on the wrist is the wrist, and we call that the radial pulse. Hence the radial artery against the radial bone. Okay? So you got the carotid arteries, subclavian arteries. As the subclavian arteries enter the arms, they become the brachial artery, and from the brachial artery, they are turned into the radial artery. And that's the same on both sides, left and right arms. Okay? So you have the aorta from the heart, and that supplies the entire body. It's the main line that goes down the body. Okay? The artery is the largest, the aorta is the largest artery in the body. As it goes down, it will supply blood to your kidneys, to your stomach, and then right around your belly button area, it breaks in half. It divides like a wishbone. It divides into the common iliac. Okay? Goes down the left leg, goes down the right leg. Right in the groin area, right at the top where your leg meets your hips, right around that area, that's where it turns into your femoral artery. And your femoral artery is your main artery that supplies your legs with blood. Okay? From there, it goes all the way down to your toes. And then from there, the blood comes back, the veins start, and the vein brings the blood all the way back up to the heart via the superior inferior vena cava. Now, when you have blood from an artery, which is the big tube, in order to get down to the fingers and the fingertip, you need a really, 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 really small tube. Unfortunately, arteries don't go all the way down to our fingers. Okay? So you have an artery, and as the artery gets smaller and it branches off to supply blood to your fingers and the top layers of your skin, that's what they call arterioles. So it goes from an artery, which is the big guy, branches off, starts to go down, then it becomes an arteriole. And arterioles are very, very small, but they still carry oxygen-rich blood to all the different parts of your body. Okay, it goes into your muscles and such. And those arterioles turn into what we call capillaries. Capillaries are the smallest portion. They're at the end. They're at the end of arteries, but they're at the beginning of the veins. A capillary is where perfusion takes place. And if you don't know what the definition of perfusion is yet, I'm going to tell you right now. Perfusion is the adequate and constant supply of oxygen, nutrients, and minerals to all organs and tissues of the body, and also supplies the waste removal of waste from those organs and tissues as well. So you have your artery, breaks down to the arteriole, then it goes down to the capillary. And the capillary is down where all the cells are in your body, where your muscle cells are and such are. And it almost looks like a fish netting, like what I was talking about in the lungs. Remember I said that you got the capillaries that are on the outside layer of the alveoli, and then oxygen goes through that membrane, okay? Goes through, and then CO comes through, and that process is called diffusion, okay? Same thing happens down the body. How can the blood get from the artery into your muscles? It does that by the artery supplying blood down to the arterioles, down to the capillaries, and it's like a fish netting. And then it goes, and then diffusion takes place. Oxygen is delivered, CO is picked up, minerals and vitamins, and the whole process is perfusion. And then as the oxygen is kicked off the blood, CO comes on, and then the blood keeps going around. Now it's going to start heading north. It's going to start heading back towards the heart again. Now it enters, the artery turns into a vein. And then you got the vein And you got the venules, and then you have the vein. So the venules are the very small microscopic parts of the veins, and then you got the vein, which is the main line that brings the blood back to the vena cava and then to the inferior and superior vena cava. So you've got the arteries and you've got your veins, big pipes. As they go throughout the body, they get smaller, and the arteries turn into arterioles, and the veins turn into venules, and they both meet up down here at the capillaries or the fish netting, and that's where diffusion and perfusion takes place. Okay, so the blood comes from the artery, arterioles, down to the capillaries, exchanging gases, nutrients, waste, enters the veins, or to the venules, to the veins, and back to the heart. Okay, I hope I explained that to you in a way that you can understand that. Pulse. What is the pulse? We check a patient for the pulse. Okay, we know what the normal pulse rate is for a patient. How do we check it? Well, we can check it at the carotid. We can check it at the brachial, which is on the inside of the bicep, tricep, okay, where they meet. You check at the radial. You can check at the popliteal, which is behind the knee. You can also check it at the dorsal pedis, otherwise known as the pedal pulse, and that's on the top of the foot. You've got your top of the foot, and this is your big toe. You're going to go to the top of the foot. You're going to go a little bit on the outside, and at your left foot, top of the foot, this is the big toe, and just go a little bit to the left, and you can feel the pulse there. You can also feel it behind your ankle as well. Okay, so there are a couple places where we can check the pulse at. Okay, we talked about blood pressure. When you're taking somebody's blood pressure, you have a high number and a low number. The high number represents the pressure that's in the arteries when the heart is squeezing, and that's your initial pressure that's caused, and that's what we feel. Okay, we feel the pulse. Okay, when you're taking the blood pressure, that's called the systolic blood pressure. And then as the ventricles, as the heart is no longer pumping and it's relaxing and it's refilling with blood, that residual pressure that's in the cardiovascular system, that is called your diastolic blood pressure. Systolic and diastolic blood pressure. Remember those, you got to know those like you know your name. Okay? Let's see here. We talked about the blood pressure, cardiac output. Cardiac output is not something we can do in the field, just like the stroke volume is not something that we can determine what it is out in the field, because that's what doctors use, and they use certain machines that can do that. But it's good for you to know. The stroke volume, as I said, is the amount of blood that is pumped out of the heart without constriction or contraction. Okay, and what they call the cardiac output is the amount of blood that is pumped out of the heart within a 60-second period. So how they come up with the cardiac output is, okay, we know how much blood comes out of the heart every time it squeezes. Okay, every time it contracts. Now we need to know how much blood is coming out of that heart every 60 seconds. So what they do is they take how many times does your heart beat in 1 minute, multiplied by the volume that comes out of the heart with each beat. Okay, so let's say you pump out 10 cc's of blood with every time your heart squeezes. Okay, and you do that you count that number of times for 1 minute, and that becomes your cardiac output. Okay, we don't know what that quantity is, but what we can tell out in the field is when we take a blood pressure, do they have a blood pressure that's right where it should be, or is the blood pressure low, or is it high? If the blood pressure is low, that means something's wrong with the heart. Why is the heart not creating the amount of blood pressure within the body that it should be? Something's wrong. Is it a problem that just came out of the blue? And it's acute? Acute means it just happens, it comes on very quickly. Or is it chronic? It's there all the time. The person has a constant low blood pressure. Okay, or if the blood pressure is extremely high, is it an acute situation, or is it a chronic situation? Is it acute, it just happened, or is it chronic, the person always has high blood pressure? Okay, you'll find that people who are older, people who are overweight, they tend to have higher blood pressure, so it's chronic blood pressure, otherwise known as hypertension. Okay, so we can tell if somebody's heart is working correctly or not, because if the blood pressure is too low or too high, or if the pulse is too low or too high. Also, what I talked to you guys about is cyanosis, when you have discoloring around the lips and the mouth and the nose, that shows that there's poor perfusion. Okay? And what is perfusion again? Perfusion is the adequate supply of oxygen, mineral, and vitamins to all the tissues and organs of the body and the removal of waste. So if you're breathing properly and your heart's working properly, then most likely your body is in what we call homeostasis. I talked to you guys about that chapter 15. And that means everything is working well. And you have good perfusion. Good perfusion is adequate amounts of oxygen, minerals and nutrients of the organs and tissues of the body, and the removal of waste. Okay? When you have poor perfusion or inadequate perfusion, then is it the heart? Is it the lungs? Is it both of them? What's going on? And that's what we as EMTs have to try to figure out in the field, and we have to do it very quickly. Okay? So we talked about the areas where we can check for the pulse on the human body. Let's see here. Let me see. Okay, cardiac input. Okay, let's talk about pathophysiology. Page 636. Pathophysiology. Chest pain or discomfort that is related to the heart usually stems from a condition called ischemia. Ischemia, which is decreased blood flow, in this case to the heart. Okay, because of partial or complete blockage of blood flow through the coronary arteries. Remember, the coronary arteries are the arteries that supply the heart muscle with its own blood. Okay, while blood's going out through the rest of the body to our lungs and to our fingers and our skin and our stomach and our butt and our legs and our toes, the coronary arteries are the arteries that supply the heart. Okay, so there might be a blockage, a total blockage, a minor blockage. Okay, and when you have a blockage of sufficient blood flow through the coronary arteries of the heart tissue, it fails to get the oxygen and nutrients that it needs. And the heart muscle is a big baby. If it doesn't get what it wants, it's going to complain. And when the heart doesn't get enough blood and oxygen and nutrients, it's going to complain. And it complains how? With chest pain. It's going to make you pay. It'll say, hey, I want my oxygen, I want my nutrients, I want my blood, give it to me. And it's going to go, oh, chest pain. That's heart's way of saying, hey, I'm talking to you here. Okay? So what can block blood from getting to the heart? Couple of things. Number one, you can have something that's called arterial sclerosis. You have arterial sclerosis and you have arterial sclerosis. Okay, they're spelled fairly similar and they sound fairly similar, but make sure you guys read them up in the book. They are different. Arterial sclerosis is when you have your arteries that are supposed to be this wide, okay? But you get a buildup of plaque and calcium and guck. Sort of think of a water pipe at home. And the water pipe, brand new, coming from the store, is nice and wide. But after 20, 30, 40 years of being under the ground, you get all this crap that builds up on the inside of it, and the diameter goes from here to here, okay? Well, in a pipe, that's crap, that's gunk. In the human artery, that's called plaque and cholesterol. And that builds up. And it makes the diameter smaller and smaller and smaller. So instead of having a pipe this wide with blood flow going through it, it's going to be this small. So the heart says, well, if my pipes aren't nice and clear like this and they're like this, that means I have to work harder because I still have to pump the same amount of blood through them as I would to pump sufficient amounts of blood through the body. So the heart's going to have to work harder. Okay? High blood pressure, high pulse rate. Okay? Because it's got to work harder. Okay? Sometimes, so that's arterial sclerosis. When anything starts to block your airway or anything starts to block an artery or a vein, is called an occlusion. Okay? An occlusion is a blockage. You can have a partial blockage, which is a little bit of blockage, or you can have a complete blockage, okay, which is a total occlusion, complete occlusion, okay. Sometimes when a piece of arteriosclerosis breaks off, it flows through the body until it gets to a point where the artery it's going through just starts to narrow down to an arterial, and all of a sudden it blocks it. So now there becomes an occlusion. Is it a partial occlusion where blood can still get by it? or is it complete occlusion, which has blocked it off completely, and anything beyond that blockage isn't getting any blood? Okay, so in that case, it's ischemia when we're talking about the heart muscle. Okay, that ischemia with the heart muscle can, number one, it's going to give you a lot of pain, and it's going to cause tissue death if that occlusion is not taken care of, if it is not removed fairly quickly. Okay, now the difference between cardiac arrest and a heart attack. Okay, cardiac arrest is when your heart is no longer pumping blood sufficiently to support life, and that's when you've got to use an AED and you got to do CPR. Okay, that's cardiac arrest. A heart attack is when there's a blockage in the coronary arteries and the blood vessels of the heart that keeps the entire heart from getting all the blood supply that it needs, or a portion of it. So part of that heart muscle will start to die. And that gives you the heart attack. So what do? Lots of things we can do. First, let me go back a little bit. When you have, okay, so if the piece of gunk that breaks off does not occlude the artery at the location, the blood clot occlusion, same thing. The occlusion or the blood clot is what causes it. Okay, if it does not occlude the artery at the location, the blood clot may break loose and begin floating in the blood, becoming what is known as a thromboembolism. Okay, a thromboembolism. Thromboembolism is when a piece of that calcium or crap breaks off and it causes, and it's floating around your system. That's called a thromboembolism. Okay, when it gets stuck somewhere and it makes a blockage and it decreases or stops the blood flow beyond it, then that's called an occlusion. Partial occlusion, complete occlusion. Okay. Tissues downstream from the blood clot or the occlusion will have a lack of oxygen, which is hypoxia. If blood flow is not resumed in a short time, the hypoxic tissue will, if the blood flow is resumed in a short time, the hypoxic tissue will recover. It'll be back to normal. However, if too much time goes by before the blood flow is resumed, the hypoxic tissue that doesn't have enough oxygen, will die. And once tissue dies, it doesn't come back. If a blockage occurs in a coronary artery, the condition is known as an acute myocardial infarction. Okay? Infarction means tissue death. So acute myocardial infarction. Acute, what I said earlier, means that it comes on suddenly. Okay? Myocardial or myocardium is the heart. So acute myocardial. Very fast heart infarction. Infarction means tissue death. So because we're talking about the heart, the tissue that's dying is the heart muscle. So acute myocardial infarction, quickly or fast heart death of tissue. Okay? So an AMI heart attack. Okay? The same sequence may also cause the death of cells in other organs, such as the brain. So you get a blockage in the heart, and it starts to block or occludes a part, or partially or completely occludes one of the arteries in the heart. You have a heart attack. You have a blockage of blood flow due to a blockage in the brain. It's called a stroke. To remove these blockages, to correct these occlusions or partial occlusions in the heart or the brain, there are certain things we can do. You guys will learn about the brain later in the book, but today we're going to be concentrating on the heart. Okay? So that's what happens. So if you do not get that occlusion, partial or complete occlusion, taken care of fairly quickly with that patient, by getting to the hospital, and the doctors can go in and remove that thromboembolism to remove that clot that's causing the occlusion, the blockage. the heart will start to work harder and harder and harder to start making up for it, but the heart can only work harder for so long. Then it's going to say, oh, the heck with it, and it's going to give up. And it's either going to stop or it's going to start acting it's going to start pumping very, very irregular. When a heart pumps irregular, that's called an arrhythmia. Okay? When it's an irregular heartbeat, the heart's supposed to go. If for some reason there's an occlusion with that heart and it's causing the heart to do something, it's an arrhythmia. It's an irregular heartbeat. It can be skipping a beat. It could be making the beat come too fast, too slow, whatever. Okay? But that can only happen so long, and the heart will start to get really, really tired, and then it'll say, the heck with it, I give up, I'm going to stop working so hard, and it gives up. And then you've got cardiac arrest. Cardiac arrest is when there is no perfusion taking place, and then that's when you got to do CPR. Okay? Heart attack, well, it really, really hurts. Okay, take them to the hospital, they give them some medicine, it goes away. Cardiac arrest is, it really, really hurts. They don't do it for a while, and all of a sudden the heart stops. Now you got cardiac arrest. Okay? So, okay. Let me see here for a second. You have something that's called the acute coronary syndrome. You know what? We're going to go and stop this here. I'm going to take a quick 5-minute break, and I'll be right back, everybody. Take care. Talk to you soon. Bye.